Today we're doing section, the fifth set of notes on radicals, and we're going to be talking about the inverse function. So just a quick review on some vocabulary you're going to see today. Recall this is like back from the very first chapter of Algebra 2 that any set of coordinate pairs is called a relation, but we can have a more specific type of relation, and that's what we call a function. So there's a rule for that. So the rule for a function is that your x values cannot repeat. So when you look at these two t-charts, this first one is what we call a function because there is no repeating x values. And again, a function is a relation, so this is still a relation, it's just more specifically a function. Whereas the second one is not a function. And the issue that we have is the x values that are repeating right here of 4. So that's why that one is not a function. So that's how we would do it algebraically. If we're looking at it graphically, which is letters C and D in your paper, the one on the left is a function, and the one on the right is not a function. And this is because it fails the vertical line test. And we can abbreviate this as VLT. So if you kind of recall from the beginning of the year, if I were to draw a vertical line anywhere, notice it intersects twice, and that's why it's failing. Whereas over here, it's only going to intersect one time. To kind of relate it to what we did before, notice this x value is 3 here and a 3 there. So again, the x values are repeating, which is the same idea as what we did earlier. So we're going to go to the bottom of the page where it says finding the inverse. So the inverse essentially means that all your xy values flip-flop their place. So this first coordinate of negative 1, 1 is going to become 1, negative 1. The second coordinate will become 2, 0, 3, 1, and a 4, 1. So we're going to plot these points, and I'm going to do this in the first one in blue. So I have negative 1, 1, 0, 2, a 1, 3, and a 1, 4. Now I'm going to plot my second set of values. So I have a 1, negative 1, a 2, 0, a 3, 1, and a 4, 1. And the question says, graph S and then its inverse in the coordinate plane below, which we did. And it says, how does this line y equals x relate to the graph? So the line y equals x is a straight line with a slope of 1 that goes right through the origin. So if you were to look at this line, you should notice that there's symmetry. If I were to fold the graph along this line, the picture appears the same on either side. So you should always see that kind of relationship when you're graphing a function and its corresponding inverse. So on the next page, we're going to talk about how to actually find the inverse of a function, not just a set of coordinate pairs. Off to the side in your paper, we're just going to make a quick little list of the process. So the first step is to switch x and y. The second step is to solve for y. So in example 2 on letter A, the first step I would do is to switch x and y. So you literally keep the format the same, you just take x and y and you flip-flop their spots in the function. And now my goal is to solve for y. So to solve for y, I subtract 3 from both sides. So I have x minus 3 equals y squared. To get y by itself, I need to take the square root. And because we are taking the square root, you introduced it into the problem, we need to use a plus or minus. So plus or minus the square root of x minus 3 is the inverse of the original equation that we did. So for letter B, I asked you to graph the original function and then its inverse. So I'm going to switch my screen so that I have a graphing screen. And we're going to use these two equations to kind of create our function. So our original equation is y equals x squared plus 3. So I'm going to say let's go from negative 2 to 2. So if I plug in a negative 2, I have a negative 2 squared plus 3. So a negative 2 squared is 4. 4 plus 3 is 7. Then I have a negative 1 squared plus 3, which is 1 plus 3, which is 4. 0 squared plus 3 is just going to be 3. And then 1 squared plus 3, again, is going to be 4. And 2 squared plus 3 will also be 7. So we're going to plot these points. So I'll go to negative 2, 7. Negative 1, 4. 0, 3. 1, 4. And a 2, 7. And you should be thinking to yourself right now that this looks familiar. This is a parabola. This is quadratics, which we spent a significant amount of time on graphing. And now to find the inverse, I take all these coordinates and I flip-flop them. So I simply just change the values in their placement in the x and y. And then I'm going to plot these points. So I have a 7, negative 2. I have, a 4, negative 1. A 3, 0. 4, 1, and a 7, positive 2. So again, you should notice that you see some symmetry happening. So here is this line y equals x going halfway through, and you should see that the symmetry is happening on either side. So this is my original function. This one over here is my inverse. So letter C says, does y equals x squared plus 3 define a function? So this is our original function up here. So yes, it is a function. And it says, what is its domain and range? So my domain is going to be from negative infinity less than x less than infinity, because I can plug in any value and square it. My range is y is greater than or equal to 3. So that goes with this piece. Now we're going to state the domain and range of this piece right here. So letter D says, is the inverse a function? No. So that is not a function because that would fail the vertical line test. Use a different color. So it's going to fail the vertical line test if I were to draw a vertical line. Regardless if it's a function or not, though, it still has a domain and range. It still has x and y values. It just has repeating x values. So notice when I look at this graph, my domain is x is greater than or equal to 3. And you can see that in your t-chart here. My x values are growing either way from 3. And my y values are going to continue to grow forever. So my range is negative infinity less than y less than infinity. So you should have noticed that the domain and range of the original literally just flip-flopped with the domain and range of the inverse. And that's because when I took my x and y values, I flip-flopped my x and y values in the t-chart. So again, literally your x and y values have changed. If you also wanted to use the equation for the inverse, which is plus or minus the square root of x minus 3, so if, for example, if I inputted the 7 minus 3 is 4, and then the square root of 4 is a plus or minus 2, which is where those two answers are coming from. So you can either use a t-chart or you can just flip-flop your t-charts by hand, or you can plug in x and y values to find it. So let's go through one more. So the next page, the top says notation for inverse. So the way we pronounce this is the inverse. So the way we say this is the inverse of f. Okay, so that's the way we would pronounce that. So letter A for example 3 says, what is the domain and range of f of x? So I know I have a domain instruction. I can't input any value I want into my t-chart. I can only use values that are bigger than -1. So my domain has to be x is greater than or equal to -1. And when I use the domain of -1, if I plug -1 in, I get a y value of 0. So my range has to be y is greater than or equal to 0. If that really confused you, we will be able to use the calculator and you'll be able to look at the graph. So that is fine with me for that part. So I'm going to again switch the screen so that we can make our graph out of this equation. So my equation is y equals the square root of x plus 1. So again, we already determined that the smallest value I can use is the -1. When I plug in -1, we'll get the square root of 0, which is 0. So the next value I can take the square root of is 1. So I need to plug in a 0. So 0 plus 1, I'll get 1. Next value we can take the square root of is 4. So I need to input a 3. So 3 plus 1 is square root of 4, which is 2. And then I can take the square root of 9. So I'm going to input an 8. So 8 plus 1 is the square root of 9, which is 3. And again, I'm not putting the plus or minus here because the square root was already there. I didn't introduce it into the problem. So we're going to plot these points. So I have -1, 0, a 0, 1, a 3, 2, and an 8, 3. And it's going to grow this way. And now to find my inverse, I just flip-flop these values. So I have a 0, -1, 1, 0, 2, 3, and a 3, 8. So I have a 0, -1, a 1, 0, 2, 3, and a 3, 8. So again, you should still see the symmetry. This time the functions are actually overlapping or crossing one another, and that still is okay. They still have this symmetry over this line of y equals x. So I kind of want to head a step for letter C. So letter C says find the inverse and sketch its graph. So we sketched the graph. Now I want to know what the actual equation is for the inverse. So I'm going to go back a screen to find the inverse. So this is part of letter C. So remember, f of x is a fancy way of saying y. So I'm going to say y equals the square root of x plus 1. And now we switch x and y. And now the goal is to solve for 1. So I need to square both sides to get y by itself. So I'll get x squared equals y plus 1. And then subtract 1 from both sides to get y by itself. So the inverse function of f is equal to x squared minus 1. So that's our equation for letter C. So we kind of graphed the function ahead of time, and now we went back and found the equation. So I'm going to go back to the next screen to do letter D and E. So notice letter D and E say state the domain and range of our inverse function. So my domain, notice my x values are greater than or equal to 0, and my range, my y values are greater than or equal to -1. So again, if you look it up at letter A, you should notice that the domain and range literally flip-flop from before. And lastly, letter E says, is it a function? Yes. And it says explain, and you could say because it passes the vertical line test. So that's all for today. We're going to pick up with this lesson tomorrow.